Hello students, welcome to Sri Joyendra's Ring Zone classes. I am your friend and mentor for coming classes with respect to physics. This is lecture number 5 of a unit system of particle and rotational motion. So let's begin with today's class. In today's class we are going to continue discussing moment of inertia. It is a part 2 of a moment of inertia. In the previous class we have started the moment of inertia, and the basic formula for the moment of inertia is that, let's suppose this is the rotational axis. Here the object m1 is there and perpendicular distance from this is x1. Then I can say moment of inertia, let's suppose this is rotating like this in this direction with certain omega, let's say. Then the I that we call as a moment of inertia would be equals to m1 x1 square. If we have multiple masses, let's say this is m2 and this is x2, such as this is mn and this is xn, this distance. So it's an m1 x1 square plus m2 x2 square plus m3 x3 square up to mn xn square. And we can write this as a sigma I is equals to 1 to n mi xi square. I hope this is clear. Is it clear? Is it? Are you sure? Are you sure? Can we do it? Can we do it? Great. So now first we are going to discuss on the different theorems of moment of inertia, and then we will use the practical applications of moment of inertia. So let's just look at the theorems on the moment of inertia. First, first is the perpendicular axis theorem. This theorem is applicable for a rigid body that lies entirely within a plane. It means it is a laminar body. You can call it, this is limitation, that this is applicable to only laminar bodies only. Or we can say this can be a rod bent into a shape of a plane curve. So let's suppose understood that this is the x-axis, this is the y-axis, this is the z-axis. And according to this theorem I could write this at Iz is equals to Ix plus Iy. So for a planar body, the moment of inertia about an axis perpendicular to the plane of the body. It says that, I repeat it, the moment of inertia about an axis perpendicular to the plane of the body is the sum of the moment of inertia about two perpendicular axes in the plane of the object, provided that all three axes are concurrent. Yes, so I can write it's an Iz is equals to Ix plus Iy. At this point of time, you just remember this formula. We are going to use it in our application of today's session. Yes, so this is first that we call as an perpendicular axis theorem. I need to focus it that this is applicable for laminar body only. If it is not laminar body, if it is not entirely lying within a plane, we could not write this first thing. And the formula is Iz is equals to Ix plus Iy, while I understood that x, y and z are perpendicular to each other. Have you done with this? Great. Next is the parallel axis theorem. Next is the parallel axis theorem. That, let's suppose this is one of the body and this arbitrary shaped body is having mass m, and this is the location of center of mass of this body. Let's suppose one of the axes has been passed from the center of mass, and I required a moment of inertia from this. So let's have a look. It says that consider a body of arbitrary shape and mass m as shown in the figure. Its moment of inertia IO and IC are defined the two parallel axes. These two are the parallel axes, and the axis about which moment of inertia IC is defined passes through the center of mass C, and separation between this IO and IC is the R. If these two are parallel, then this two moment of inertia can be related by IO is equals to IC plus m into xc square. This distance in my case, in this situation, is ICOM. It's an I center of mass plus m into r square. So this is the parallel axis theorem. One of the very good freedom is this can be applied to each body, every body. You do not need to bother that this are lying on the same plane, they are concurrent or not. Only the thing what you required, please listen this, only the thing you required is the only the thing you required is this and this should be parallel. Yes, and this can be defined for center of mass only. Yes, so I see it's an I center of mass that the that rotational axis should be passed through the center of mass of that body. It is only the limitation, or it is only, we can say, the requirement. I hope this is clear. Now what we are supposed to do is we are going to observe the moment of inertia of different bodies. I'm sure that you have derived this. You have derived the formula of each and every shape in your school classes. So, as I am not covering this because this is the theoretical session that you have already covered in the school session, so we will just focus on, we will merely focus on the applications of this. I'm sure that you have done this. Yes, so let's just summarize. This is just the summary that this can be revised. So let's take a first. It's a uniform thin rod. It's a uniform thin rod bent into a shape of an arc of mass m. You can consider this as a ring as well, but it is a quarter section, or we can say a certain section theta of ring. Now axis, from where axis will be passing? Axis will be passing through the center and perpendicular to the plane containing the arc. So it would be something like this, that has been passed through the moment of inertia. Then moment of inertia for this, it's a m into r square. Now uniform ring sorry, uniform ring of mass m, and moment of inertia passes through here. That means it's a passing through center and perpendicular to the plane containing the arc of the centroidal axis, and moment of inertia, it would be defined as m into r square. Now it would be a straight uniform road, and the axis, that means rotational axis, has been passing from the midpoint. Yes, it's a passing through the center and perpendicular to the road. Then that could be given as m into l square by 12. Let's suppose and rotational axis passes through here. This is we call as in first case, this is I1, and let's suppose this is second case. This I2 would be equals to ml square by 3. Yes, please do remember these things. Yes, if your straight uniform road is being rotated from the end point of the road, then it could be written as ml square by 3. Next, it's a sector of a uniform disk. This is disk of mass m, from where rotational axis is passing from here. So if it is passing through the center and perpendicular to the plane, it is perpendicular to the plane containing the sector, then this would be the mr square by 2. Yes, so for ring, this is for ring. For ring it is mr square, for disk it is mr square by 2. If road is rotated from the midpoint, it would be ml square by 12. If the road is rotated from the end point, it is ml square by 3. Does it clear? Does it? Great. Next, it's a uniform disk of mass m, that we understand it would be a mr square by 2. And when we are talking mr square by 2, it is the case when axis of rotation is being passed through the center and perpendicular to the plane. Got it? Now next, it's a homogeneous cylinder of mass m. It's a homogeneous cylinder of mass m. Then if it is rotating through its axis, it's an axis of the cylinder. If it is being rotated from the axis of cylinder, then this could be written as mr square by 2. We will discuss it in more detail, that how this mr square by 2 has been arrived, but at this point of time you just remember this, it's an mr square by 2. Next, it's a homogeneous sphere. It's a homogeneous sphere of mass m. Then if it is a sphere of mass m, this will be the 2 by 5 mr square, and from where rotational axis will passes, it's a diameter or the centroidal axis. When I say it's an homogeneous sphere, when I say it's an homogeneous sphere, This is the solid sphere. This is the solid sphere we are talking about, and it's a spherical shell. It's this could be written as the hollow sphere as well. So if solid sphere or homogeneous sphere, it is 2 by 5 mr square, and if hollow sphere is there, it is 2 by 3 mr square, and the rotational axis is being passed through the diameter or the centroidal axis. So it is not the case that only this are the moment of inertia that I require to remember. There are more too, but initially you need to remember this, and let me add two or three to this. One of them is, let's suppose we have this square plate. The square plate is having mass m, this is having length l, and this breadth b, and its moment of inertia is this. It's a perpendicular to the plane containing the rectangular plate. So its moment of inertia will be given as m by 12 into bracket l square plus b square. It is the case. Next case is of square plate. Next case, it is the square plate. This is l, this is l. Yes, its mass is m, and rotational axis passing through here, rotational axis passing through this. So if it is the case, then I would be equals to, it is the same, it's a m by 12 into bracket l square plus b square, but now as it is the square, it's an l square plus l square. So this will be equals to m by 12 into bracket l square plus l square, it is 2l square. So this would be ml square by 6. So please do remember this. Please do remember this. And shall we begin with the applications of perpendicular and parallel axis theorem? Shall we? Can we? Great. So let's just begin our questions. Find out mi for the given axis of rotation. So they say that, let's suppose this is a disk having mass m, this is its center, and this is, let's say, radius r. So first it is like this. Which axis does it? Which axis does it? We say this, that this is x, this is y, and z axis is perpendicular to this too. That means it is the, what you need to do is draw a circle in your book, have your pen or have your pencil which is perpendicular to this disk, which should be perpendicular to your notebook. Yes, which is perpendicular to this disk, and that is passing through the center, what we call as an IZZ or IZ. IZZ, the value is fixed, that we have remembered, we have as well shown this, it's an mr square by 2. So IZZ, this is first requirement, it was mr square by 2. Now let's suppose if I need to rotate this from here, then which axis is it? Look at this, this is x axis. So let's call it, this is x dash, this was z dash. Now how could I find it out, x dash? I am having only the value of IZZ dash, and I can relate z with the x and y according to the perpendicular axis theorem. So what I can write is IZZ dash is equals to IXX dash plus IYY dash. Does it clear? So I can write, it's an IZZ dash that should be is equals to IXX dash plus IYY dash. Now according to the symmetry, according to the symmetry, IXX dash and IYY dash are equal. So what I can have is the IXX dash is equals to IZZ dash divided by 2. Yes, so that would be equals to mr square by 4. This was IXX dash, or even if I have been asked to calculate this, this is I dash. This would be the same. This is I dash. I hope this is clear. So this is I dash, which should be is equals to mr square by 4. I hope this is clear. Is it clear? Is it? Is it? Shall I go ahead? Shall I? Are you sure? Great. So this was the case. This was the case, and this is the disk having mass m, radius r. Yes. Now, what do you know? You know the IZZ, which is mr square by 2. You know the IXX and IYY, which is mr square by 4. Yes. Now, what you need to do is, you need to find out the moment of inertia from this. Yes, this axis is parallel to the plane of the disk. This axis, let me write this as 1 1 dash. It's an I 1 dash. It is on the plane of the disk. On the plane of the disk. Yes, diagram has been shown, so you must understand what would be the situation. So what could you do? This is the radius r that I understand. What I understand is that this axis is parallel to IYY axis. Look at this. IYY has been passed through this. This is YY dash. And IXX dash has been passed through this. This is XX dash. So what does it, where from where it is flowing? Yes, yes, it is parallel to the IYY dash, as well as IYY dash axis is passing through the center of mass. So according to the parallel axis theorem, what I can write, it's an I11 dash is equals to I center of mass plus m into d square, or it's an m into r square. Now ICM, that is IYY dash, is passing through here, and IYY dash, it's an mr square by 4 plus mr square, which should be is equals to 5 by 4 mr square. I hope this is clear. Does it clear? Does it? Does it clear? Are you sure? Great. Now let's work for this. This is again in the plane of the paper, and this is 2 dash. So how will you do it? How will you do it? What I understand is this I22 dash could be written as, this axis is parallel to this axis. It is parallel to the XX dash. And when this I22 dash is parallel to the XX dash, what I can write is, this is ICM plus m into d square. Yes, here it is parallel to XX dash. So when it is parallel to XX dash, I should write it's an mr square by 4 plus mr square. When I write this, it is 5 by 4 mr square. I hope this is clear. Is it clear? Is it? Shall I do one more thing with this in the same diagram? Shall I? Can I do this? Can I? Great. Let's have a look. One of the axis is passing through this. Yes. This is, let me call as an 3 dash. Yes. What you need to do is, where does it? Where does it? What is your mind saying? Is it perpendicular to the plane of the disk or parallel to the plane of the disk? Where does it lying? Where does it? Yes, you are absolutely right. It is perpendicular to the plane of the disk. And when it is perpendicular, to the disk, what I need to write is, this 3 dash must be, the parallel to the IZZ. Yes, so this is I33 dash should be is equals to I33 dash, that should be is equals to I center of mass plus m into d square. and as it is parallel to the IZZ, the IZZ is having a value of mr square by 2 plus mr square, that should be is equals to 3 by 2 mr square. I hope you this is clear. Is it clear? Is it? Now what you need to do is you need to find out one more, but on your own. This is 4 4 dash. So you are going to find this. It's an I44 dash is required. I hope this is clear. Is it clear? Is it? So will you be do this? Can we? Can we? Yes? Okay, great. So is it clear up till now? Is it? Is it clear? Is it? Great. Now this is one of the question for you guys at your home. It's a try yourself. So the situation is, let's suppose this is a circular ring. This is its center. This ring is having uh, it is a ring having mass m, radius r. What you need to do is you need to find out the moment of inertia. First this, yes, that is I z z dash. Second this, it's an I x x dash. Third this, it's an I y y dash. The fourth in this plane, it's a 4 4 dash. Next it is something like this. Next it is something like this. This is 6 6 dash. Yes, one more, which is, yes, it's a 7 7 dash. I hope this is clear. One more. Let's suppose this is the axis. It's, let it write down as an 8 8 dash. So this is I 8 8 dash, as well as this is 9 9 dash. So I 8 8 dash, I 9 9 dash would be what? So this is the requirement. Yes, what you need to do is you need to do it one by one. This is the basically the combined question of 1 2 3 4 5 6 7 8 9 9 questions. Yes, please do it on your own. It's it's do it yourself. I hope this is clear. So can you do this? Can you do this? It is the same thing. It is almost the same thing. Only the difference is that this was disk and this IZZ was mr square by 2, and from this you have derived everything. Now here, as it is the ring having mass 7 radius r, its IZZ is mr square only. It is not mr square by 2, and so on. You can carry on. I am sure for this. I hope this is clear. Is it clear? So can you do this? Can you? Any doubts in this up till now? Is there anything? Is there anything? No? Great. Well done. Let's work for the next question. Let's suppose, let's suppose mm, a solid sphere of mass m and radius r is rotating as shown in the figure. A solid sphere of mass m and radius r is rotating as shown in the figure. Find out. Am I? Mission impossible or moment of inertia? What is it? Yes, it's a moment of inertia. So what I need to find out, I need to find out the moment of inertia. How will I do this? How will I do this? So what I need to do is, let's suppose this is the solid sphere. Yes, and let's understood that this is having mass m and radius r. So first you are going to rotating it this from here. You must understand that this is sphere, and as it is a sphere, it is symmetrical. It is symmetrical over its z axis, x axis, y axis. So we can write this, it's an I z z dash, or you could write I x x dash, or you could write I y y dash. From this I have written this from the symmetrical nature of sphere. Yes, it would be same in every dimensions, no? It's an whether it is in x or whether it is in y or whether it is in z, it is symmetrical. That's why it is a 3D object. Yes. So let's suppose write this as a I11 dash, and that we understand that when and when we rotate the sphere from its diagonal, from its any of the diagonal, it could be like this, or it could be like this, or it could be like this. Yes, whatever it could, when and when we pass it through diagonal, even this would be the diagonal. If you observe this in a 3D, if you observe this from here, as we have drawn this on the 2D, that why it looks like it is in not the diagonal, but assume this in a 3D view, then you will feel that yes, I11 dash or I22 dash or I33 dash, both all will be 2 by 5 mr square. I hope this is clear. Is it clear? Is it? Are you sure? Now, second question. Let's have a look. It is passed through this. This is 2 2 dash. So what will you do? This I22 dash. It is parallel to whom? Yes, it is parallel to 1 1 dash. So what I can write is, it's an I22 dash is equals to I11 dash, because even 1 1 is passing through the center of mass, because the center of mass of solid sphere will be at the center. So this I22 dash will be equals to I11 dash plus m into r square. This is equals to 2 by 5 mr square plus mr square, and that tends to 7 by 5 mr square. Have you got this? Have you? Are you sure? Are you sure? Okay, great. So can you do this? Can you? Are you sure? Are you? Great. Now, one thing for you. This is 4 4 dash. Yes, and you need to do this. It's a I44 dash, it's on you. But I can give you the hint. Now tell me, this 44 dash is parallel to what? This I44 dash is parallel to what? Yes, it is absolutely parallel to 2. So what you need to do is, it's an I44 dash should be equals to I22 dash plus m into r square, and the whole thing will be the same. So does it clear? Does it clear? Can you do this? Can you? Are you sure? Can we do this? Yes. Let's work for the next question. Do it quickly. You are doing pretty good. Seriously. Yes. This is not possible to observe this and to feel this, but you are feeling it. Very good. Nice. Well done. Keep working. Let's suppose this is one of the sphere. This is another sphere. This is one more sphere. And let's say a one and last. Yes. and rotational axis is being passed through this. All the spheres, all the solid spheres, sorry, all the solid spheres are having mass m and radius r. The solid spheres are having mass m and radius r. If they are rotating, if they are rotating as shown in the figure, find moment of inertia. This is requirement. So what I need to do is, let me give them a number. It's a first, it's a second sphere, it's a third sphere, it's a fourth sphere. So if you observe the first sphere and fourth sphere, if you observe the first sphere and fourth sphere, they are just rotating from the diameter. Yes, axis of rotation, let's suppose they are rotating in this direction, then the axis of rotation has been passed through the diameter. So what I can write is, it's an I1 should be equals to, they are the solid sphere, it's a 2 by 5 mr square. Even same thing is true for I4 as well. So I1 would be equals to 2 by 5 mr square, as well as I4 would be equals to 2 by 5 mr square. Now let's look about the 2 and 3. Let's work for the any one of them. Let's work for the 2. So the second sphere, it is rotating like this, that this is axis of rotation, and it is rotating something like this. Yes, so here it's a center of mass, and if I draw parallel axis, then this would be the parallel axis. Yes, this you can say this is y dash, and this is I required. That means we call this at this instant it's an I2. So what I need to do is, I need to apply a parallel axis theorem over here, and if I apply parallel axis over here, then that could be written as I center of mass plus m into r square. When I call this it's an I center of mass, this is equals to 2 by 5 mr square plus mr square. While I write this, it is 7 by 5, 2 by 5 plus 1, this is equals to 7 by 5 mr square. Even this was the situation with 3 as well, even this was the situation with 3 as well. So even I3 would be having the same value. Yes, because even if you look at this, this is being rotated from here. Yes, and that axis, the rotational axis, is parallel to its y-axis. So this is I2, this is I3. Now what I need to do is, I need to find out the I total, or I should say it's an I of the system. So I can write like this, it's an I1 plus I2 plus I3 plus I4. When I write this, it's an I1 plus I2 plus I3 plus I4. This I1 would be equals to 2 by 5 mr square. This I2 could be written as, 7 by 5 mr square. This I3 could be written as, 7 by 5 mr square. This I4 could be written as again 2 by 5 mr square. So it's a 2 plus 2, this is a 4 by 5 mr square, plus 7 plus 7, it is a 14 by 5 mr square. And this could be written as 4 plus 14, it's an 18 by 5 mr square. So this is moment of inertia of the system. That means this amount of inertia is required to be break if you need to rotate it. Or you can say this, that this amount of inertia this system already contain, and if you need to rotate it, or if you need to change the status of this system, you need to provide external inertia of this much amount. So does it clear? Does it? Are you sure? Are you sure? Can you do this? Can you? Great. So shall I do one more question for you guys? Shall I? Let's have a look. That let's suppose this is the first object and this is the rotational axis. This is the second object. This is the third object. And okay, let it be continue with this. Yes, this was first object, this was second object, this was third object. They are going to rotate it in this manner from the given rotational axis. The first object is the solid sphere. The second object it's a hollow sphere. The third object it's a ring. Yes, shall I draw the ring as well? Or shall I draw the disk as well? Let's have a look. Yes, this is fourth object and fourth object is disk. Each one is of same mass m. Find moment of inertia. This is requirement and this is the do it yourself kind. You are supposed to do this. Not supposed to, you are going to do this. I hope this is clear. This is it? Can you do this? Can it be done? Can it be? So can we do this? Are you sure? Are you? Great. Now let's take one more object and let's play with it. Let's suppose the question is that let's take a road. Yes, this is having mass m, length l, and the question is find mi. From where? Let me tell you. First, from here, it's a 1 1 dash. What it would be? Yes, it is the rotation of the road from its center. It is the rotation of the road from its center. And when I am when I am rotating this from its center, what I can write, it's the I11 dash is equals to ml square by 12. This is what we have remembered. Yes, now next, let's suppose it is being rotated from here. It is being rotated from here. So this is I22 dash, which should be given as I22 dash, that should be equals to ml square by 3. Yes, this is 22 dash. Now let's find it out. This one, this is from here, this distance is at l by 2, sorry, l by 4, my mistake. This is l by 4 and this is required. How will you do this? How will you do this? So what I need to do is that I, let's suppose this is 3 3 dash, I 3 3 dash, that should be is equals to I center of mass plus m into d square, it's a distance. Now I center of mass, it's an ml square by 12 plus d square, it is a l by 4, it's an m into l by 4 whole square. So this is equals to ml square by 12 plus ml square by 16. So this would be equals to 16 ml square plus 12 ml square divide by 12 into 16. So this is 18 ml square, sorry 28, sorry my mistake, it's a 28 ml square divided by 12 into 16. You can solve this, and this is the required moment of inertia. It's an I33 dash. Does it clear? Does it? Any doubts, any Anything? No? Let's look at this question that in the previous question we were supposed to do. Yes, it was for the roads. And let's suppose the question is there that suppose this is the rotational axis. This is one of the road, and this road is having mass m, length l. This angle is theta, and this you need to rotate this with this rotational axis. So the question is find out moment of inertia. This is the requirement. How will you do this? How will you do this? So what I understand is that this is the end point of the road and this is the length L. So if I make a component, this should be the L cos theta and that should be the L sin theta. Yes, this would be the L cos theta and the another would be the L sin theta. So when I used to define I, which is the moment of inertia, then I used to call it as an m into x square, where x was the perpendicular. Please remember this, it's a perpendicular distance from rotational axis. So always I require a component which is perpendicular from the rotational axis, and that is the L sine theta. So what I need to do is that I'm going to write it's an m into x square, while my x would be the L sine theta, but as if I will take this L sine theta as a component, then I must understand that this is the end point from which my object is rotating. It is a road. So my master formula would be equals to ml square by 3, but I used to write this as an L dash because L dash is going to be replaced by the L sine theta. So the final answer would be m by 3 multiplied by L square sine square theta. This is what the moment of inertia of this situation. I hope this is clear. Is it clear? Is it? Is it? Any doubts over this? Anything? Any doubts? Are you sure? Any doubts? Is there anything? Is there? No? Great. Now, let's take the next question. Suppose we have the square plate. Yes, this square plate having dimensions of, let's say, L. The dimensions is for L by L, and the mass is the m. I write it here. Yes. So the question is find moment of inertia of a given square plate. So now let's define one by one the rotational axis and you will give me the answer that what would be the value of moment of inertia for this rotational axis. First, let's suppose it is at midpoint and perpendicular to the plane of the paper. So what you need to do is draw up square plate. Please mind well, this is square plate. Initially when we used to have this kind of questions in the previous part, it was the part 1, it was just the just 4 roads were there, they have been connected but that are the massless. So this those question and this question is totally different. I hope this is clear. Now how will you do this? Which axis is it? Yes, absolutely right, it is IZZ. And when I used to say this is IZZ, what I need to say is it's an ML square by 6. Am I clear? Let's call it this is I11 dash. Yes, so this is I11 dash. Now let's take it the different one. Yes, this is XX, this is YY, this is, let's say I call it this as a 22 dash, and I call this as a 33 dash. So how could I do this? I need to find out now I22 dash and I33 dash. As I understand that this is the laminar object and when laminar object is there, I could write it's an IZZ is equals to IXX plus IYY. According to the symmetricality, it's an IXX, that is IYY. So that is, I can say it's an IZZ should be equals to twice of the IXX, and if it is twice of the IXX, it would be IXX is equals to IZZ by 2. When I say it's an IZZ by 2, this is ml square by 12. This is IXX, or you can use this as an IYY. I hope this is clear. Is it clear? Is it? Are you sure? Are you sure? Great. Now let's look for the next question. Suppose rotational axis is being passed from here. Let's say this is a 4 4 dash, and one more rotational axis is passing over here. Yes, you require a value of this. It's a 5 5 dash, I 4 4 dash and I 5 5 dash. How will you find it out? How will you do it? What do you understand? How could I do this? So if you are not having any idea, please have a look at this. That if you say that this is my x, then you can say so that this is my y, and this could be the z. Yes, it's within the paper or outside the paper, but perpendicular to this. So this three, x, y and z, this three are the perpendicular to each other, and we can use the izz is equals to ixx plus iyy and all that stuff. Okay, great. Now what, when look at this condition, that is the 4 4 dash or 5 5 dash condition. So can we say so? Look at this very carefully. Let's say suppose this is 4 4 dash and this is 5 5 dash. Yes, it's a 5 5 dash, and this was already there as a zz dash. So can I say this, even this 3, that means 4 4 dash, 5 5 dash and zz dash are perpendicular to each other, and they even form a group like izz is equals to ixx plus iyy. Can I say so? Can I? Now do you have any idea? Yes, great, some of you might got this. So I can write like this, it's a I 4 4 dash or I 5 5 dash. They will just behave as an ixx or iyy. So they are going to have a value as an ml square by 12. Got this? Did you get this? Did you? Now do you understand this completely? Do you understand this? Any confusion over this? Is there anything? Is there anything? Do you understand this completely? Do you? Are you sure? Are you sure? Great. So shall we move to the next applications of the square plate? Shall we? Let's have a look. Let's suppose this was the situation. This was the square plate having length L. This is having length L, and the mass given is M. Now what you need to do is, you need to rotate this. You need to rotate this from here. Let me call this as a 6 6 dash. How will you do this? How will you do this? That this 6 6 dash, this 6 6 dash is perpendicular. It's a perpendicular to the plane of the square plate. So if what I understood is that even here I am having one of the rotational axis that I call as a ZZ dash. So I assume that, and I consider that IZZ dash and I66 dash are parallel to each other. So this is L, this is L, this total, I can say this total distance is root 2L, and this is just the half of the distance. So this is root of 2L divided by 2, which could be written as L by root 2. So let's just check it out what I66 dash is all about. It's an IZZ dash plus m into L by root 2 whole square. While IZZ dash, it's an ml square by 6 plus ml square by 2. If I write this, it is ml square by 6 plus 3 by 6 ml square. This would be 4 by 6 ml square. And while I write 4 by 6, it's a 2 by 3 ml square. This is I66 dash. Did you get this? Did you? So, is it clear? Everything completely crystal clear? Is it so? Is it so? Do you understand each and everything? Any doubts over this? Do you have any doubts over this? Is there anything? Is there? Now, do you understand this thing completely and 100%? Are you sure? Are you sure? Great. So now let's work for the next questions. It is a next category questions. So let's suppose, let's suppose, suppose the situation is something like this. You will say it was the initial situation only. I will say no, this is not. In reality, this four roads are there. These are the four roads. Yes, each one is having mass m length l, and this is their midpoint. So four roads having mass m and length l are connected as shown in the figure. So four roads having mass m and length l are connected as shown in the figure. Find out. Am I? Mission impossible? No. Moment of inertia from let's call it as a ZZ dash. ZZ dash. Yes. So how will you do this? Now how you supposed to do this? How can you? Any idea? Any idea how shall I do this? What I can do is that let's took any one of the road. This is one of the road, and from here I am going to rotate it. So I can write this is a distance of L by 2. So this road is going to be rotated. Yes, this axis, that is the center of mass axis of the road, and this axis, this is the required axis. So what I can write is that let's suppose this is IZZ dash is equals to, for this it's an ml square by 12 because it is being rotating from the midpoint, plus m into L square by 4. Yes, m into y square, this is just the distance which we call as a L by 2, but this is about only one of the roads. So I can write IZZ dash total should be equals to 4 times of ml square by 12 plus it's a 3 ml square by 12. So ml square plus 3 ml square, this is 4. It's a 4 into bracket 4 ml square by 12. I hope this is clear. So this is 4 by 3. This should be written as 4 by 3 ml square. Got this? Do you? Do you understand this completely? Are you sure? Are you? Yes? So can you do this? Can you? Great. Ready for the next question? Are you ready? Are you sure? Let's have a look. The next question. Same way, a triangular section has been made up. Three roads having mass m and length L are connected as shown in the figure. Find out. Let's say 1 1 dash, and this is 1 1 dash. Yes, it's a perpendicular to the plane of this rectangular frame, because these are the roads. When roads are going to connect it, they cannot create a complete rectangular sheet. They can create only the rectangular frame. I hope this is clear. So what I need to find out, I need to find out the 1 1 dash. How will I do this? So again, I'm going to do the same thing that we have done previously. This is the road, this is the location. Yes, all roads are having same dimension, so it is something like this. This would be 30 degree because this is angle bisector, this is 60 degree. Yes, this length is L, so this half of the length would be the L by 2. Why I am doing this? Because I need to find out this distance y. So how will I do this? It's a 10 30 degree, that should be is equals to y divided by L by 2. It's a 2y by L. While the 10 30, this is equals to 10 30, it's a 1 by root 3, that is equals to 2y by L. So y is equals to L by 2 root 3. Does it clear up till now? Now I require this. It's a 1 1 dash. I know this, it's a center of mass, so I can write it's an I 1 1 dash, that is the equals to I center of mass plus m into y square. So this could be written as I center of mass, it's an ml square by 12 plus m into y square, this is L square divided by square of the 2 4 root 3, it's a 3, it's a 4 plus 4 into 3 12, sorry, and this for totality multiplied by 3, because this was talking about the one of the road only. When I'm doing this, it's a 2 ml square by 12 multiplied by 3. This is 3 fours and this is ml square by 2. This is I 1 1 dash. So have you got this? Have you got this? Are you sure? Are you sure? Can we do this? Is it possible? Is it possible by you guys to do this? Are you sure? Can it be done? Can it be? Are you interested in very good questions? Yes. Uh, High on the concept. Are you? Let's have a look. Let's suppose I am having two roads. Something like this. I have arranged them. Both are having length L and both are having the same mass. From where do I rotate it? I need to rotate it from here. It's a perpendicular to the plane. So the question says that find out mi for the given system. So how will you do this? Take 30 seconds of your time and just think that how this could be achieved. Very good question. Yes. Can you do this? Will it be? So let me help you guys. What we need to do is that give them a number. This is first road, this is second road. For first road, it is being rotated from the end point. Yes. So what I'm supposed to write is this I1 should be is equals to, both are having a mass of m, mass of m. So I1 could be written as it's an ml square by 3. Yes, and I need to find out now I2. How will you do this? How could I do this? So if you observe this things very carefully, this is perpendicular to the plane. That means this required axis is perpendicular. Even at this center, this is the center where center of mass would be there. So this distance would be the L by 2, this distance would be the L by 2. What I need to do is I need to find out this distance. Let's look at this. This is the center of mass location, and this is the rotational axis. So I must look for this. This is, let's say, y. Yes, and this is L. This is L by 2. So this y square should be equals to L square plus L square by 4, which should be, it's an L square plus L square by 4. This is 5 by 4 ml square. So I2 would be, it is first rotated from here, which is the midpoint, of this road. That could I return, it's an ml square by 12 plus ml square by 12 plus 5 by 4 ml square. This is the moment of inertia of second road. So for the total system, for the I of the system, moment of inertia of the system, what I need to do is it's an I1 plus I2. And while I am doing this I1 plus I2, this is ml square by 12, this is ml square by 3. So this could be, let's write it as a 4 ml square by 12 plus ml square by 12 plus, it's a 4 3s and 5 3s, it's a 15 by 12 ml square. So this could be written as 4 plus 15, 19, 19 plus 1. It's a 20 by 12 ml square. Now you can solve this and get it done. 4 3s and 4 5s. So it would be a 5 by 3 ml square. But do you understand this completely? Do you? Can you understand this? Are you sure? Any doubts over this? Is there anything? Is there anything that you don't understand? No, because this is the aspect that we required a lot during the whole unit. Is it clear? Is it? Great. Now let's work on the cylinders. Let's suppose a cylinder is there. Let's first work with the hollow cylinder. This is the length of the cylinder L. This is the radius of the cylinder, and its mass is m. So the question says find out mi for the given system. So let's just find it out first. This, let's assume this is hollow cylinder. This is 1 dash. So what is it? So what you are supposed to do is, when 3D objects are there, when any 3D objects are there, that needs to be converted to the 2D. That needs to be converted to the 2D. And when this needs to be converted to 2D, what I can have I11 dash is, I will observe a circular ring. Why? Because this is hollow. If I am going to convert this 2D to 3D, I can assume this as a circular ring. If it was solid cylinder, I will assume a circular disc. So this I11 dash could be written as m r square. That's it. It's an I11 dash. It's an mr square. If I wish to rotate it from this point, it's a center of mass location. This is 2 2 dash. So when I go for the I22 dash, I must understand that it will first behave as a road which is rotating from the midpoint. So that could be written as ml square by 12 plus plus. Now if you are going to compress, if you are going to convert this into a two dimensions, this is the y-axis. This is what we can say, that when I do this, first I will observe this like this, and next I will observe this like this. Yes, and this is a ring because this is hollow cylinder. So this could be written as m r square by 2 because this is the y dash. I hope this is clear. Is it? Is it? One more? Would you like to have one more question on this only? Yes, let's have a look. If you want to look this, if you want to rotate this from here, it's a 3 3 dash. What would be the situation? So for the 3 3 dash, one of the situation would be you will look this road as it is, something like this. Yes, and then again this situation remain the same. So this could be written as it is moving, or sorry, as it is rotating in the at from the end. This could be written as ml square by 3 plus mr square by 2. I hope this is clear. Was it clear? Was it? Are you sure? Are you? Any doubts? Is there anything? Is there? So do you understand this completely? Great. Well done. You are doing nice thing. Very good. Next, let's say, let's say this is the, previously it was hollow cylinder. Now this is solid cylinder having mass m, having this radius as r, having this length as an L. So the question is find mi of given system. This is requirement. Find moment of inertia of given system. So what I need to do is, let's first, it's an axis. This is, previously it was hollow cylinder, now this is solid cylinder. Call this as a 1 1 dash. So I 1 1 dash, when I convert this, I found this. Yes, so as it is solid, that is completely filled, so it will look like a disc which is rotating on z axis. So when disk rotating on z axis, when disk rotating on z axis, what I can have, it's an m r square by 2. This is I11 dash. Now let's rotate it from here. Yes, in this direction. This is 2 2 dash. If I rotate this from here, it's an I22 dash. That would be, first I will observe this. I will observe this as a rectangular road which is rotating from the midpoint, and then I will observe it just like y direction. So I22 dash could be written as ml square by 12 plus plus this is Iyy, it's an mr square by 4. So this I22 dash, that should be written as ml square by 12 plus mr square by 4, and let's rotate it from here. This is 3 3 dash. So this I33 dash could be written as T something like this. Yes. So this I33 dash is equals to this is ml square by 3 plus mr square by 4. Have you got this? Have you got this? So can you do it? Can you? Are you sure? Can it be done? Can it be done? Are you sure? Are you sure? Great. So, shall we move to the next question? Shall we? Let's have a look. Find out. Am I of given systems? Let's suppose they say that this is this is a ring having mass m and radius r. What you need to find it out? You need to find out, let's suppose this is 1 1 dash. So I understand that I11 dash, I11 dash, it's an IZZ axis in reality because it is the perpendicular to the plane. And for ring, the moment of inertia across Z axis, which is a perpendicular to the plane of the disk or plane of the ring, sorry, it would be just the mr square. Now, please understood that you are not supposed to say this, that sir, this is half of the ring, so I am supposed to divide it by 2 and everything. No, it is not possible, because when data has been given, when data has been given, they have mentioned that this is ring, it is having mass m and radius r. So for this ring only they assume that this ring is having, or this many segment is having a mass m, and their moment of inertia would be equals to mr square. I hope this is clear. Is it clear? Is it clear? Even if they say something like this, look at this, please have a look at this, and please don't be in the confusion, make it clear. Let's say if they say that this is a ring, only this many segment, and this is angle theta. They say that if circular arc is there, and this arc is having mass m, and this arc is having radius of r, find out the moment of inertia, something like this, it's an izz dash, then again I will write it's an mr square, because what I understand is for this segment only, from here to here, they cover a mass of m. I hope this is clear. Is it clear? So do you now having any confusion? Do you have any confusion? Do you? Are you sure? Now do you have any confusion? Anything? Are you sure? Are you? Great. So, we must be very clear while writing it down the moment of inertia. Yes, that when they have given certain sections, it may be we will find out that this section is whose look alike. That means if let's suppose they say that this is the disk having mass m, having radius r, and what they want the moment of inertia that has been passing through this. So when they want this, that this is the moment of inertia that has been passed through this, that izz dash would be is equals to mr square by 2. In that situation, I am not going to discuss that, no sir, mr square by 2 would be for the complete disk. This is just half of the disk. How could I write mr square, or how could I write mr square by 2 for this? It is not the case, dear. I hope this is clear. That when we used to call them, they have mentioned it that this segment contains a mass m, and when they say this segment contains a mass m, we need to understand that this is the mass m. I hope this is clear. Is it clear? Is it? Now do you have any confusion? Is there anything? Is there anything? Are you sure? Are you sure? Great. So now, ready for the next question? Are you? Great. Let's look at the question. Let's suppose this is a semicircular ring. Shall I read through? This is, yes, this is semicircular ring, and it is something like this. Yes. So this is the center. This is the R. The center of mass of this semicircular ring would be over here, and this distance is 2r by 5, that we must know. If you don't know, don't worry, now just remember this. So let's suppose a certain axis has been passed through this. Yes, from here it's a, when I make a cross, it means that it is the perpendicular to the plane of the paper, that you understand now. So what they want, that find out moment of inertia of the given semicircular ring from its center of mass. So this is required. We need to rotate this ring. We need to rotate this semicircular ring from its center of mass. And I have been asked that how will I do this? What would be the moment of inertia for this situation? So what will you do? Yes, tell me what could be done. Any idea? Any idea what is to be done? What is supposed to be done? So what I understand is that, let's say this is the ZZ axis. Yes, so I can write like this. It's an IZZ dash is equals to I center of mass plus m into d square. Yes, IZZ dash is equals to I center of mass plus md square, because this ZZ dash and this center of mass, these two are the parallel with each other. Now for ring, IZZ dash is the mr square. ICM, that is what I am looking for, plus m into d square. This d should be is equals to 4r square divided by pi square. So for this situation, I center of mass should be is equals to mr square minus of 4 by pi square multiplied by m into r square. And while you are doing this, this I center of mass should be is equals to mr square into bracket 1 minus 4 by pi square. Have you got this? Have you got this? Are you sure? Are you sure? If I if I understand pi square approximately equals to 10, if I take this, then it's an mr square into bracket 1 minus 4 by 10, which is zero point 0.4. So this is mr square multiplied by zero point 0.6. This is the moment of inertia through center of mass. I hope this is clear. Is it clear? Is it clear? Does it? Are you sure? So will you do as one of the question based on this? Let's write this, that if semicircular ring of previous question has been replaced by, if the semicircular ring of previous question has been replaced by semicircular disc, find out I center of mass. So the situation is something like this. This is the center R. Sorry, this is the center and this is the radius. This is the center and this is the radius. For this segment, mass given is m. For this segment, mass given is m. Its center of mass would be somewhere here, and this is, let's say, phi. Have you remembered the value of y? Have you? No? Okay. It is 4r by 3 pi. It is 4r by 3 pi. Now, what I'm supposed to do is, yes, I'm going to do the same thing, that this is required, this is given. That means I z z dash is none, and I center of mass is required. So what I will do is that I z z dash is equals to I center of mass plus m into y square, that we have done previously. But this is semicircular disk. This is semicircular disk. So I z z dash would be equals to mr square by 2. This is equals to ICM plus m multiplied by y, and the y is 4r by 3 pi, so it's 16r square divided by 9 pi square. Yes, so it would be the ICM, that would be equals to mr square by 2 minus 16 by 9 pi square into mr square. I hope this is clear. Is it clear? Is it clear? Yes. So now you can solve this and get the answer in kg into meter square. Have you got this? Are you sure? So can you do this kind of questions? Can you? Is it possible for you to do this? Are you sure? Great. So let's just wind it up the session over here. In this session we have covered many of the questions of the moment of inertia, but this is not limited to this. Yes, so please attempt so many questions that will give you certain new patterns, new applications of the questions as well. But you need to attempt many of the questions. If so many questions is going to be attempted, at least 300 to 400 questions of moment of inertia only. Yes, if those amount of questions can be attempted, we would be able to solve the questions of moment of inertia not only in 11 but even in the 12th, because we are not going to forget it if we have been passed through the 300 to 400 questions of mi only. Yes, so please do this, please do this. This is required. One more request to you guys is, please do not forget to revise the center of mass, because it was the concept which is going to help us in the topics when we are going to discuss about the rolling and the rotating. Yes, so please do this, please revise it as soon as possible, and please do as many questions as possible. Thank you, have a good day, take care, bye.